Hello everyone, I am Sai Kiran. I am completed my BTech third year in Electrical and Electronics Engineering at AP Tupet RGKT RK Valley, Idgulpaya. I am here to share my experience in embedded systems, which is powered by Emertxe Information Technologies, and to give presentation on project washing machine simulation. Firstly, I would like to express my heartfelt gratitude to Emertxe for providing me with the opportunity to intern in embedded systems. This experience was truly invaluable, and I am grateful for the skill and the knowledge I gained during my time there. Working on washing machine simulation project using PIC 16F877A microcontroller, MPLAB and PicSimLab tools was an incredible learning experience. I got to apply critical concepts to real world problems, and it helped me develop a deeper understanding of embedded systems. I want to thank the mentors Anusha ma'am who covered the C language module and Gopriya ma'am who covered microcontroller module for their guidance and support throughout the internship. Their expertise and mentorship were enhanced my knowledge. I am confident that the experience and knowledge I gained will benefit me in my future endeavors. Thank you again to Emertxe for this amazing opportunity. I am proud to have been a part of the internship program. These are the things I learned during the internship. Basics of C, embedded C, introduction to embedded systems, what is microcontroller, what is microprocessor and what is the difference between them, required tools to develop project, peripherals used for project, implementation of project and project demonstration. Implementation of project and project demonstration will be covered by my friend Kalyan. Introduction to C language. First we have to know what is C. C is a powerful general-purpose programming language that provides low-level memory management and efficient execution. It's a fundamental language that has been widely used for decades, and its influence can still be seen in many modern programming languages. Where C is used? C is used in a variety of applications such as system software development, embedded software development, OS kernel development, firmware, middleware, and driver development, file system development, and many more. Next, features of C language. As you can see here, these are the main features of C language. First one, general purpose and portable procedural programming language, low level memory access. One of the unique features of C language is its ability to provide low level memory access. Next, fast speed. Next, clean syntax. Next, data types. Data types define the type of data a variable can hold. Here data types are generally classified into three categories: primitive data type, derived data type, user defined data type. First, primitive data types. These are the basic types provided by the programming languages, including character data types. It is used to store single character. Next, integer data type. It is used to whole numbers. Next, floating point data type. It is for numbers with decimal points. Void data type. It is used to indicate no value or return type, especially in functions. Next, derived data types. These are derived from the primitive types, including arrays, strings, pointers. Arrays. Arrays is a collection of elements of the same type. Next, string. String is a sequence of characters. Pointers. Pointers are variables that stores the address of another variable. Third one, user-defined data types. These are the customized by the programmer to better represent real-world entities, including structure, union, typedef, enum. Structures allows grouping of variables of different data types. Union, similar to structures but with shared memory space. Typedef, it is used to create a new names for existing types. Enum, it is defined a set of named integer constants. Each type plays a crucial role. Understanding them is essential for project building. Conditional constructs. Conditional constructs help us to make decision in code, similar to how we make decision in real life based on a certain condition. We broadly classified into two categories: single iteration constructs, multiple iterations. Single iterations. These are used when we want to check a condition and execute a block of code only once. This is divided into two types: if and its family. This includes if else, and if else if statements. This allows us to execute different blocks of code based on a different conditions. Another one, switch case. This is a cleaner alternative when we need to choose between multiple fixed options based on a single variable. Multiple iteration constructs. These are the loops used when we want to repeat a block of code multiple times based on a condition. Under this, for loop, while loop, do while loop, divided. For loop, best used when the number of iterations is known. While loop, it is used when the number of iterations is not known and depends entirely on condition. Do while loop, it is similar to while, but here the loop runs at least once before the condition is checked. These conditional constructs give our code flexibility and control. They help us to build logic that can adapt and make decisions dynamically. Operators. Operators are special symbols used to perform operations on variables and values. In C, there are several types of operations. Operators, each serving a special and specific purpose. Let's look at each type one by one. Arithmetic operator. Arithmetic operator, these are the used for basic mathematical operations like addition, subtraction, division, modulus and multiplication. Next, relational operators. This helps in comparing values, and we use it to check relations between two variables like greater than or equal to, less than or equal to, like that. Next, logical operators. These are used to combine multiple conditions. The common ones are and, or, and exclamatory mark for not. Bitwise operators. These operate at the binary level and are used for bit level operations. Next, increment and decrement operators. These are shorthand operators to increase or decrease a variable value by 1. Plus plus is used for increment and minus minus is for decrement. Next, assignment operators. The operator used to assign a value to a variable. These are all different types of operators in C. Next, functions. A function is a self-contained block of code designed to perform a specific task. Think of it like a small mission inside your program. You give it some input, it does a job and may give you output. Functions are extremely important in C because they help us break large programs into smaller. They improve modularity, reusability and organization. That means we can write the logic once and reuse it whenever we need it, which makes our code cleaner and easier to debug. Now, how do we use functions in C? There are 3 main steps: function declaration, function definition, function call. In function declaration, this is where we tell the compiler about the function's name, return type and parameters before using it. It usually goes at the top of the program. Next, function declaration. Here we write the actual logic of the function, what the function is supposed to do. Function call. This is when we actually use or call the function in the main program or another program. Now let us know about the embedded systems. Embedded systems is a combination of hardware and software built specifically to perform a dedicated task. Unlike general purpose computers that can do multiple things, but embedded systems are task specific. They are optimized for performance, reusability and efficiency to complete a particular job within a given time. To simple understanding, imagine a small computer built into a machine or device just to control or monitor a certain function. These are some common examples: a smart TV, digital camera, washing machine, micro oven. These devices may seem ordinary, but they all run on embedded systems, silently managing tasks behind the scenes. Components of embedded system. An embedded system is made up of several key parts. At the center, we have the system core. This is heart of the embedded system where all processing happens. It connects and controls all the other components. As you see the connected components, microcontroller or processor. These are the brain of the system. They can be general processors like microcontrollers or specialized hardware like DSPs, FPGAs, ASICs or SoCs depending on the application. Next, memory. This stores both the code and data used by the system. It includes both RAM and ROM depending on whether the data is temporary or permanent. Next, input ports. This receives data from the outside world. For example, sensors or buttons send information into the system through input ports. Next, output ports. This sends the system response or action to the outside world. For example, turning on LED or activating a motor. Next, communication interface. This is used when the embedded systems needs to talk to other devices. It includes protocols like UART, SPI, I2C and many more. Like other devices. This could be additional components like timers, ADCs or watchtags that suppose the main functionality of the system. Let us see the types of embedded systems. Embedded systems can be categorized based on how they operate and connect. First, standalone and slave embedded systems. This works independently or as part of a bigger system, like a washing machine controller. Next, network embedded system. These are connected to network for remote control or data exchange, like smart home devices. Third, real-time embedded systems. It's need to respond within strict time limits. These are further divided into three. Hard real-time, where missing a deadline can be fatal, like in pacemaker or airbags. They need to respond within a time. Next, firm real-time. Deadlines are important but occasionally misses are tolerable. Next, soft real-time. Perform is important but timing is not critical, like in video streaming. Next, mobile embedded systems. These are portable and often battery powered, like fitness trackers. Last one, hybrid systems. This combines features from multiple categories for versatility. Microcontroller. Microcontroller, which is compact integrated circuit used to control specific functions in embedded system. It combines a CPU, memory like RAM and ROM, and input-output peripherals on a single chip. Look at the architecture. This CPU is the brain, handling processing. RAM and ROM manage data and code storage. Timers. Timers help with timing operations. Input-output ports handle communication with external devices, and the serial communication ports is used to connect with other systems or devices. Microprocessor, which is a single chip CPU that handles all the main computing functions. It integrates 5 major units. Arithmetic and logic, for it is used to calculations and decisions. Control unit to direct operations. Register arrays for temporary storage. Memory unit for storing instructions and data, and it connects with input and output devices for communication. Essentially, a microprocessor is the brain of a computer or general purpose system, and it widely used in desktops, laptops, mobiles and industrial applications. PIC16F877A microcontroller. In this project, we worked with the PIC16F877A microcontroller, which is an 8-bit device widely used in embedded system. It comes with 40 pins, out of which 33 are used for input and output operations. It has 14.3 kilobytes of program memory and 368 bytes of RAM. The CPU can process around 5 million instructions per second, making it efficient and real-time embedded task. As you can see here, this is the block diagram of PIC16F877A microcontroller with 5 ports. Port A, Port B, Port C, Port D and Port E. Port A. Port A connected to push button, to potentiometer, relays, 4x7 segment multiplexed display, RTCs. Port B. Port B is connected to 8 LEDs, 6 push buttons, 3x4 keyboard. Port C. Port C connected to fan tachometer, heater, serial and I2C, EPROM, delays, buzzers. Port D. Port D is connected to 3x4 keyboard, 4x7 segment multiplexed display, 8x8 LEDs, PS2 LED, LED 6x2. Last, Port E. Port E connected to temperature sensor and LCD display. These are the connected peripherals to the PIC microcontroller. These are the tools required to develop the project. First, MPLAB. It acts as host. Host is a system which is used to develop the target. Second, X8 compiler. It acts as cross compiler. It is an application is used to convert the source code to machine understandable code. Next, PicSimLab. It acts as target. Target is a system which is being developed for specific application. code compiler run. We write code in MPLAB XIDE, that source code converted into mission understandable code using XC8 compiler, and it saved as .hex file. That hex file we dumped into PicSimLab microcontroller. These are the peripherals used for project. LED switches as digital keypads, interrupts, timers, CLCDs, buzzer and fan. First one, LED. LED stands for light emitting diode. It is a semiconductor device that emits light when electric current passing through it. It is the simplest device used in most on embedded system applications as feedback. It works just like diodes. Low energy consumption, longer life, smaller size, faster switching make it usable in wide applications feel like home lighting, remote control surveillance, displays and many more. This is a symbol of diode, anode, cathode, long thin rod is anode and small thin rod is cathode. Next, second one, switches as digital keypads. Tactile switches can indeed be used as digital keypads, providing a physical and audible click to confirm input, making them suitable for various applications like keyboards, remote controls and industrial control panels. These switches are designed to give a distinct physical sensation when pressed, which can enhance user experience by confirming that a key has been actuated. As you see the first image, it is tactile switch, and second image, it is combination of tactile switches called digital keypad. Third peripheral is CLCD. CLCD stands for liquid crystal display. These are display devices. These are used to convey information through arrangement of pixels. Graphics and text LCDs are the most common type available for electronic products. Mostly this is used for display ASCII characters, some customized in symbols possibles. There are two types of modes, 8-bit mode, 4-bit mode. As you can see the image, it shows 16:2 digital display. Fourth one is buzzer. A buzzer is a sound producing electronic device. It is used as an audio signal device. It typically produces a buzzing or beeping sound when activated and is commonly found in alarm, timers and other electronic devices. Fifth one is fan. A washing machine motor is an electronic motor that provides the mechanical power to rotate the drum for washing and spinning clothes. It converts electrical energy into rotational motion, enabling the washing and drying cycles. Sixth one, interrupts. An interrupt is a communication process set up in a microprocessor or microcontroller, in which an internal or external device requests the MPU to stop the processing. The MPU acknowledges the request, attend to the request, goes back to processing where it was interrupted. As you see the image, it shows interrupt handling. First one, this is normal execution flow of program. See here, an interrupt is occurred. If interrupt is occurred, the main execution stops and it goes to solve interrupt block and it return back to the main. It continues execution. This is interrupt handling. Classification of interrupts. There are mainly divided into two categories: hardware interrupt and software interrupt. First, hardware interrupt. Hardware interrupts are generated by external devices like keyboards or timers. These are further classified into non-maskable, maskable. Non-maskable interrupts are critical and cannot be ignored, like power failure alert. Maskable interrupts, which the CPU can choose to ignore or delay. These are again divided into two types: external, internal. External interrupts triggered by external hardwares. Internal interrupts triggered by internal conditions such as a timer overflow. On the other side, software interrupts are generated by program to request system level services like system calls. And the last thing is timers. In an embedded system, a timer is a hardware component often integrated into microcontroller that counts clock cycles to measure time intervals or generate time-based events. It is used for tasks like creating delays, triggering actions at specific time, and measuring the duration of events. Timer 2 is used for this project. It's used for precise timing, generating delays, and creating pulse width modulation signals. Allows simulation of real-time washing durations without blocking program flow. About the implementation of project and further topics will continue by my teammate Kalyan.
Firstly, a warm wishes to everyone. I am Mr. Kalyan, currently pursuing my BTech 4th year in the stream of Electronics and Communication Engineering. I am the kind of person who is very enthusiastic to learn new things and make them in a very smart and unique way. Now let's dive into the topic. Yeah, previously my friend has explained a brief about C, embedded systems, embedded programming, microcontrollers, specifically to say PIC microcontroller, and various peripherals he explained used in this project, and briefed you about timers, interrupts, etc. Now let's discuss about this project washing machine. Here we are simulating washing machine using PicSimLab. That means we are doing a virtual prototype, not a real hardware prototype. Okay, let's dive into next slide. Firstly, our washing machine just looks like a real life washing machine which has different types of modes for different types of clothes and different types of washing types also, like water, rinsing, spinning, washing, etc. In our washing machine, we use several peripherals like LCD for display, buzzer for alarm, motor for running whenever washing machine is power on, and various switches to control the navigations. Firstly, our washing machine will look like this LCD, like press key 5 to power on washing machine. So whenever we press switch 5 on the digital keypad board, it will display like powering on washing machine. Whenever after the powering on of washing machine, it will display washing programs. There are around 12 washing programs, like I have to select the types of clothes I have to wash in the washing machine. In these 12, I have to select one. These washing programs will scroll if we press switch 4. For selecting the option, a long press of switch 4 is required for around 5 to 8 seconds. After the long press, it will direct you to water level menu. Here we can select the kind of wash needed for the clothes, whether it is auto, low, medium, high or max. Same here also. If we press switch 4, it will scroll upward, and if the long press of switch 4 is done, then the particular level is selected. Then it will direct you to this screen. That is press switch 5 to start, switch 6 to stop. Here it will proceed you further in the washing. Press switch 5 for the start. After pressing switch 5, it will display you the function. That means in washing there will be 3 types. No, firstly wash, then rinse, then spin. And based on the type of mode, it will display the function. And for every type of mode and type of wash and the selected water level, the time will be varying. That means time will be very unique for different types of modes. For this type of particular wash, the time is 37 seconds, and it will start if we press switch 5, and it will pass if we press switch 6. After pressing switch 5, the timer will decrement from 37 seconds to 0 seconds. That means that is the washing period. After the washing period is completed, it will display like program completed, remove your clothes. In this completion status screen, it will be displayed, and buzzer will alarm once the washing is completed, and the motor which is running previously will turn off. And in this period of washing, if the door is open, it will instruct like please close. That means as we are implementing virtual prototype, here switch 1 is in our washing program, switch 1 is kept as door. That means if we press switch 1, door will be open like that. If the switch 1 is pressed, it will direct you a message of door open, please close. Otherwise, the washing program will be run as is. Yeah, now let's dive into the project demo. The code for this project is done in MPLAB XID. That means we write all the code essentials in this MPLAB XIDE, and the compilation will be done in this MPLAB compiler itself, and the code will be dumped in PicSimLab, and there the actual output will be enabled to see. Now I will show you how to create a new project, new file, etc. To create a new project, go to this file bar and click new project, And here we have to select the micro embedded standalone and proceed next. After that, we have to select all families for this all project, which will support every kind of project like basic, medium level and advanced level. We will select mid-range 8-bit MCUs. And now we are using PIC microcontroller. So we'll write like PIC 16F 877. Currently we are using this microcontroller PIC 16F 877A microcontroller. Select next. Then we have to select the compiler. That means, as I previously said, we will write the code in this MPLAB XIDE, and the compilation will be done by X8 compiler. For this, we have selected that option and proceed next. We have to name the project. That means first. Let me name first. It will be set as main project. Next, click finish. It generates all the make files which necessary for that. And here your first project is there. Here click source files. In these source files, right click. Wait once again. Right click new. Here we have to create the main.c file. Here, since it is done in C program, the extension is C. Click finish. It will again generate some new files. And it will create you a small page to write the code like this. Here we have to write all the necessary code. And if we want to create the header file, click here, same as this process new. But here we have to select header.h. In this header.h, same. The extension will be already there, and we will name the header file like first header. Let me change the spelling. First header, click finish. The header file also has been created. It is generating all the make files. Now I will show you a basic file. That means in PicSimLab. Let me explain you PicSimLab. Yeah, this is the PicSimLab board which we are using right now. Here, immediately after installing PicSimLab, we have to select the microcontrollers board we want, etc. Currently, we are using PIC microcontroller, so we are selecting PIC Genius under the board, and under PIC microcontroller, we are selecting PIC 16F87778. This is the microcontroller we are working currently on, and we have to even select the frequency, amount of frequency which we want. For this project, we are using 20, so I have set 20. And the LCD, it will be 16x2 and 16x4. As we are using 16x4, let me select this 16x4. And I will start loading our project demo. That means washing machine. This is our washing machine. Let me open the source files. Yeah, clcd.c, def.c, digital keypad.c, isr.c, timers.c. These are also .c files which we have included in our program. This is our program for this washing machine. These are all I have written in a structured manner, so it is looking like clcd.c. That means it contains all the LCD code which required. I have used them as the functions like that. In def.c, all the definitions are included. In digital keypad C, the keypad code will be included, and here are my header files, clcd.h, all the header files which are used to shorten the code in a structured manner and in a detailed manner in such a way that anyone can understand the code. Okay, let me compile this one. That is this washing machine code. I am going slowly to understand everyone. I click build main project. Yeah, here it is seen like build successful. After this, a small hex file will be appeared in this washing machine.x file. That is, we have to go to files and we have to select our washing machine.x file where it is created. I think in home MPLAB projects. Here it is. After the compilation, we have to go to PicSimLab. A small hex file is generated in that washing machine.x, and there we will load the hex. Load that hex file. Here it is. Washing machine.hex.production.hex. This is the hex file which will be understandable to the microcontroller. Yeah, I have loaded that hex file. Now we will start our demo of our working of our washing machine. Here it is displaying press key 5 to power on the washing machine. So here I am going pressing key 5. It displays like powering on washing machine, and immediately washing program display is projected. Here we have different types of modes. To move further, we have to press switch 4. If we press switch 4, it will move one variation. One can observe that it has moved upwards, and if I press long press, it will select that option and it will direct me to auto level screen. And in this auto level screen, I have to select auto, low, medium, and etc. Wait, I will scroll the options for you. Yeah, at times due to the key debouncing effect, it will not take the key press. So wait, it will load for under press also. So you can observe that it is loading high, max, auto, and again it is coming to auto. Now I will select high, long press. After the long press, it has directed me to the screen. That's mean press switch 5 to start, switch 6 to end. I am pressing switch 5 here. I have said now, due to debouncing effect, it will take a bit of time. Press the switch 5, it has displaying program function, and it has displaying as function wash. In this washing, it will be 3 types now: washing, rinsing, and spinning based on the type of mode you have selected. And it will does that for that specific time. Here function is wash. Yeah, after that washing is completed, it will also done rinse for a certain period of time as the input given in the code. Okay. After rinsing, spinning also will happen. Yeah, I will once pass for you. I have pressed switch 6 for the pass. Okay. It has been debouncing. Yeah, it has passed after the press of switch 6 in the 2 seconds, and even the fan has turned off spinning. Once I press switch 5 again to start, it will resume the operation. Like fan is rotating, and even the buzzer also have started ringing like program completed washing, like that to indicate us. I will show you another variation also. Wait a second. I will move from dedicates to wides now. Yeah, I will long press it for a while. It will direct me to water level. In this water level, I will select max now. At times, due to debouncing effect, it will not scroll. So wait until then, patiently. Selected max, long press it. It has selected the wides and max option for the water level. Press switch 5 to start. It is specifying program wides, time 40 seconds. Then it will start the function, fan will be rotating, time will be as the set in the input based on the type of mode. Yeah, if I press switch 6, let me press switch 6 for you. The program completed and the fan stopped the rotating. Yeah, here you see, and again it will direct you to the washing program, like to select the select the option for kind of flows you need. This is our project. Hope you have enjoyed it. I have shown you different options like on the types of opt for different types of cloths, the option we need to select, and different kinds of water levels we need to select, and the way it has responded, the timers like washing, rinsing, and spinning. I have to come with the control of the timers have been executed very beautifully, and that due to the debouncing effect, it is slowing a bit, that is key press, but the small issue is not big impactful. Okay. If we improve the delay, increase the delay, this problem will be solved. Now let me show you another thing. Stain wash, long press it. Scroll this option. We'll select the auto now. Press switch 5 to start. Program stain wash, time 40 seconds it will take. As it has started from 40 and moving towards 34. The function is wash. And the time is decreasing. And here we can see it will change to rinse and then spin slowly. That means it will perform all three actions based on the type of mode. Let me press switch 6 for you. Yeah, if you press switch 6, it has paused for a moment. The fan stopped rotating. Once if I press switch 5, it will again start resuming. The fan starts rotating. Let me complete this timer washing. The program has completed now. Okay, demo is completed now. Coming to the conclusion, we are very thankful to Emertxe for their service to our internship. Really, the way they have taught us, that means with the kind of patience, and they have given us access to different kinds of resources to make easy. They have provided us recordings. Overall, the guide they given for this project and this whole internship was very beautiful, and we are very thankful to them for that.